Bridge is located in Zaragoza, España. This is an innovative 270 meters long covered bridge that imitates a gladiola over the river Ebro, connecting the neighborhood of La Almozarra with the exposition site, and thus becoming its main entrance. The new bridge is at the same time a multi-level exhibition area. 10,000 visitors per hour and are expected to frequent the pavilion of the World Exhibition. During the Expo 2008, the Bridge Pavilion will host an exposition called Water, a unique resource designed by Ralph Applebaum Associates. When the expo is over, the building is expected to be purchased by the saving bank Ibercaja and remodeled into a museum related to the new technologies and weather. This emblematic structure, called the Bridge Pavilion, will be one of the expo's main entrances. This eye-catching Bridge Pavilion will be create a new order on the banks of the river Ebro, clearly distinguishable from the other expo buildings. It will provide a smooth transition between the city and the expo site, across the ramps planted with gardens and greenery. This bridge is a kind of building bridge because the structure spanning the river incorporates 4 enclosed exhibition space and combines the structural consideration of a bridge with the spatial requirement of a pavilion.
The architect chose glass fiber reinforced concrete from the Austrian company Rieder to envelop the bridge. She covered the outer skin of the building with 29,000 triangles in different gray shades of fiber steel. The building's envelope plays an essential role in defining its relation to the surrounding environment and atmospheric variations. The project has been designed to allow its interior to be thoroughly enlivened by the effect of atmospheric agents, such as the Tramontana wind blowing along the Ebro and the strength of Zaragoza's sunshine. The Zaragoza Bridge Pavilion is organized around 4 main objects or parts that perform both as structural elements and as spatial enclosures. The Bridge Pavilion design stems from the detailed examination and research into the potential of a diamond-shaped section, which offer both structural and programming properties. As in the case of space frame structures, a diamond section represents a rational way of distributing forces along a surface. The stacking and interlocking of these thrust elements, the pods, satisfies 2 specific criteria: optimizing the structural system and allowing for a natural differentiation of the interiors, where each pod corresponds to a specific exhibition space. Optimizing the structural system and allowing for a natural differentiation of the interiors, where each pod corresponds to a specific exhibition space. The Bridge Pavilion is a building designed by architect Zaha Hadid in Zaragoza as one of its main landmarks. Spatial concern is one of the main drivers of this project. Each zone within the building has its own spatial identity. Their nature varies from complete interior spaces focused on the exhibition to open spaces with a strong visual connection to the Ebro River and the Expo. The Pavillion Bridge crosses and swirls over itself like a gladiola opening and closing. It joins the 2 river banks with a central island in the river in a distinctive flowing white structure, described by the team of architects as an object rising from the natural condition of the river itself, as a symbol of water and its role in our world.
The pods are stacked according to precise criteria, aimed at reducing the section of the bridge as much as possible where the span is longer, approximately 185 meters from the island in the middle of the river to the right bank, and enlarging it where the span is shorter, 85 meters from the island to the Expo riverbank. This interlocking of the pods has given the design many exciting possibilities. Interiors become complex spaces, where visitors move from pod to pod, thought small in-between spaces that act as filters or buffer zones. These zones diffuse the sound and visual experience from one exhibition space to the next, allowing for a clearer understanding of the installation content within each pod. Natural surfaces have been investigated when designing the pavilion's exterior surfaces. For the bridge pavilion, this proves to be functional, visually appealing, and economically convenient. Many people love this project, but we found that other people say 30 technological years to come to the conclusion that bridges are better with more steel, more concrete, and more money, and more pots. Also, we found looks like a bit too much concrete to be a bridge. Quite massive, actually. What kind of bridge building research was used? Didn't the Greeks and Romans build pretty nice bridges over 2,000 years ago? Why not take some of their research? They are still standing. I doubt this bridge will stand more than 50 years. But anyway, millions of people will always think different things about a building, a bridge, or about a building bridge.